Quadratic functions can have 1, 2, or 0 zeros. Zeros are also called the roots of quadratic functions, and they refer to the points where the function intersects the x-axis. The standard form of a quadratic function is ax squared plus bx plus c equals 0. Now, this form is specifically for determining what values of x will result in y equaling 0. However, we just want to know how many values of x result in y equaling 0. So we'll set our function to equal all values of y on our graphs. Recall that the graphs of quadratic functions always form parabolas. If we set b and c equal to 0 and a to 1, then we have the simplest quadratic function possible. Y equals x squared. We see that it intersects the x-axis at only one point, the origin, 0, 0. Note that a is positive 1 here in this function, so the parabola opens upward. Now let's compare it with the function y equals x squared minus 1. The parabola has been lowered 1 unit and crosses the x-axis at 2 points. It has 2 zeros. If we change c from minus 1 to plus 1, then the parabola is completely above the x-axis, so it has no zeros. If we change the value of a from positive 1 to negative 1, the parabola will open downward, and so it will have 2 zeros. The b value can also change the number of zeros. Let's change it from 0 to minus 1 in our first function and compare that y equals x squared with y equals x squared minus x. The first function 1 0, the second 2 zeros. Now, a graphing calculator will immediately reveal the number of zeros in a quadratic function. But if you were asked this question on an exam, you most likely won't be allowed to use a graphing calculator to answer it. Fortunately, there's another simple method to determine the number of zeros. We use the quadratic formula. It can tell us what the values of the zeros are for a function, but we just want to know how many zeros there are. So we only need to use the square root part of the formula. This expression under the square root symbol, b squared minus 4ac, is called the discriminant. When the discriminant is positive, it will have both a positive and a negative square root, as indicated by the plus or minus sign. This will result in 2 zeros. When the discriminant equals 0, there will be only 1 0. And when it's negative, there will be no zeros. Let's plug the a, b, and c values from our example functions into the discriminant to compare the results. For y equals x squared, we have 0 squared minus 4 times 1 times 0, or 0 minus 0. The square root of 0 is 0. So this confirms that this function will have only one value of x that results in y equaling 0. For y equals x squared minus 1, the discriminant equals 0 squared minus 4 times 1 times negative 1, or 0 plus 4. The square root of 4 is both plus 2 and minus 2. So that's why this function has 2 zeros. For y equals x squared plus 1, the discriminant equals 0 squared minus 4 times 1 times 1, or 0 minus 4. Well, the square root of -4 is undefined. So this function has no zeros. When you encounter this type of question on an exam, you'll see that the values of A, B, and C are typically not going to be as simple as the ones that I've used in my examples. But the method for solving the problem is exactly the same. I'm an experienced teacher and tutor. I enjoy helping students understand math and grammar, and I look forward to working with you online.